Every field of science has its own terminology. The world of scientific terms in every field is dynamic rather than static. In today's rapidly expanding science, every field experiences change in its terminology, like addition of new terms, modification of definition of some existing terms, and even elimination of some previously used terms, by consideration of them as obsolete terms. In this regard, it is very important to be familiar with up-to-date terminology to avoid possible ambiguities, inconsistencies, or errors. Reasons for consideration of some terms as obsolete ones vary from term to term. For example, a term may be considered to be obsolete because it causes ambiguity or error, while another term may be considered to be obsolete because it is inconsistent with other well-established terms. In the case of chemistry, International Union of Pure and Applied Chemistry, or IUPAC, deals with chemical terminology and provides in its publications definitions and recommendations for terms used in chemistry, including terms which should be regarded as obsolete ones whose usage is discouraged or banned. In this regard, one good source is IUPAC's Gold Book with the title Compendium of Chemical Terminology, whose the most up-to-date version can be downloaded from IUPAC's website. Based on version 2.3.3 of IUPAC's Gold Book, published on the 24th of February 2014, from about 7,000 discussed terms, about 150 terms are considered to be obsolete. Of these about 150 obsolete terms, 10 terms are chosen to be discussed here as 10 obsolete terms in general chemistry. In alphabetical order, the first one from these 10 obsolete terms is dielectric constant. Instead of dielectric constant, which is considered to be an obsolete term, IUPAC recommends relative permittivity, which is defined as the ratio of the electric field strength in vacuum to that in a given medium. Our second obsolete term is Einstein. Einstein is widely used as the unit equivalent to 1 mole of photons. However, it is not an IUPAC sanctioned unit. Also, Einstein is sometimes defined as the energy of 1 mole of photons, where this use is discouraged by IUPAC. So while IUPAC doesn't sanction use of Einstein as a unit for number of photons, IUPAC discourages its use as a unit for energy of photons. Our third case is the usage of electron acceptor as Lewis acid. IUPAC considers electron acceptor only as a term for a substance to which an electron may be transferred and discourages its use as a Lewis acid. In this regard, the acceptable synonym for Lewis acid is electron pair acceptor and not electron acceptor. Similarly, the acceptable synonym for Lewis base is electron pair donor and not electron donor, where electron donor is considered to be a term for a molecular entity that can transfer an electron to another molecular entity or to the corresponding chemical species. This emphasizes that Lewis acids and Lewis bases are associated with sharing of a pair of electrons. The fourth obsolete term is hemileptic. Instead of hemileptic, IUPAC recommends homoleptic as a term for transition metal or main group compounds having only one type of ligand, like pentamethyl tantalum TAME5. It is also good to mention that in the case of transition metal or main group compounds having more than one type of ligand, the term heteroleptic is used. Our fifth obsolete term is ionization potential. Instead of ionization potential, ionization energy should be used for minimum energy required to eject an electron out of a neutral atom or molecule in its ground state. Kinetic Synergist is our sixth obsolete term here. The usage of this term as a synonym for catalyst or accelerator is not recommended by IUPAC. It is also good to know that in kinetics, the usage of negative catalyst as a synonym for inhibitor is discouraged, where inhibitor is a substance that diminishes the rate of chemical reaction in the process called inhibition. IUPAC discourages usage of negative catalyst instead of inhibitor, since the action of an inhibitor is fundamentally different from that of a catalyst. And in contrast to a catalyst, an inhibitor may be consumed during the course of a reaction. Our seventh case is the usage of peracids as a class name. IUPAC considers that peracids is an ambiguous term which may imply either a higher oxidation state of a central atom, as in perchloric acid HClO4, or a derivative of hydrogen peroxide, as in peracetic acid CH3CO3H. Accordingly, it is not recommended as a class name. In the case of acids like peracetic acid, in which an acidic OH group has been replaced by an OOH group, IUPAC considers the class name peroxy acids. The eighth obsolete term to be considered here is protolysis. This term has been used synonymously with proton-transfer reaction, a chemical reaction, the main feature of which is the intermolecular or intermolecular transfer of a proton from one binding site to another. However, because of misleading similarity of protolysis to hydrolysis, photolysis, etc., use of protolysis is discouraged. Yet IUPAC doesn't mention a similar thing for the term autoprotolysis, which is defined as a proton transfer reaction between two identical molecules, usually a solvent, one acting as a Bronsted acid and the other as a Bronsted base. So we can conclude that instead of protolysis, proton transfer reaction should be used, while there is no problem with autoprotolysis and its associated terms like autoprotolysis constant. As the ninth obsolete term, we have pseudomolecular rearrangement. IUPAC discourages the use of this awkwardly formed term and instead considers intermolecular rearrangement, which is a molecular rearrangement characterized by separation into independent fragments during the rearrangement stage and then reattachment. Our final obsolete term is stock number. IUPAC considers the term oxidation number for the charge that a central atom in a coordination entity would bear if all the ligands were removed along with the electron pairs that were shared with the central atom, and the term stock number is no longer recommended. Similarly, IUPAC considers the term charge number for the magnitude of the charge on an ion, and the term Evans-Bassett number is no longer recommended.